how to construct plots for quantitative data. In this section, we're going to look at identifying 4 key features. Make sure you put a big star, highlight, underline next to this. Must know these 4 key features that we're looking for in the plots of quantitative data. So my first warning to you is don't try and be too exact. I always use this analogy. My husband's an ER nurse, and think of this as that quick visual assessment you get when you go into the ER. They don't run any blood tests. They don't do any numbers like that. They just look at you and say, okay, are they breathing? How's their color? Is their bone sticking out? That quick, informal visual assessment before actually ordering and running any tests in laboratories. So same idea here. Don't get too worked up about being super exact. There might be more than one right answer. We're just kind of looking for ballpark ideas. Those ballpark ideas, as you will see in later sections, will inform what we do next. So perhaps one of the most important key features is shape. So shape, again, don't be worked up over this being exact. We're going to have a few different options here. So the first one we might consider is this idea of something being symmetric. So by symmetric, we mean the left side and the right side are mirror images of each other. Again, with real data, it's not going to be exact, so don't get too worked up about that. Symmetric could look like lots of different things. One of the most common examples might be something like this. The left side and the right side generally match up on this. Maybe it's something like this, where you just kind of have basically flat across, left side and right side match up. Just want to think of squinting your eyes and seeing what, if you kind of squint your eyes and look at that general pattern, could you fold it in half and have approximately the same on the right and left? The next one is this idea of right skewed data. So some people get confused about the direction of the skew. The direction of the skew is where this is trailing off. So right skewed data, the bulk of the data, is actually on the left, and it trails off towards the right. So it has this general kind of sloping down trend. Left skewed, you can probably guess what that will look like. Let's flip this around, and the tail or the pull of the data is going to be towards the left. So kind of that general trend. And then finally, we have something that's called bimodal. Bimodal, it's like the name sounds, mode means area that occurs most often. Bi means 2. So we've got 2 areas that occur with high frequencies. So maybe something like this. We have kind of 2 main areas in the data, bimodal. Bimodal, you might also be thinking, could be symmetric, and you'd be correct. So that's our first key feature. Our second key feature is center. We're just going to kind of eyeball what the center would be. There's a few ways we can think about doing this. One might be this idea of a balance point in the data. And so if we had to think about, on some of these plots, where would we put a fulcrum to balance this? Under here, that's one way to measure center. And actually, we'll see in the next section, that's exactly how the mean or average measures the center. We could also think about it as the middle point in the data. And that would be our median. So if we had to split it up, half the observations are below this, half the observations are above this. You could think of it that way. Everybody's going to have slightly different values, and that's totally fine. You're just looking at the plot and kind of eyeballing where is that balance point or middle point in the data. Our next key feature is the spread of the data. You could talk about spread relative to a different plot. So for example, if I had something on a scale of 1 to 6, and I had the data looking like this versus something else on a scale of 1 to 6, and it looked like this. By spread, a synonym that we mean here is variability. And get used to that terminology. We'll use spread and variability interchangeably in here. The x-axis is the same on both of these. We would say this first one has lower variability. Most of the data is right smack dab in the middle. Whereas the second one has higher variability because it's spread out evenly between 1 and 6. The data isn't concentrated in one place. Now, in most of our examples, we're not going to be comparing one plot versus another, though we will in a few. For now, we're just going to say it goes from here to here. Give the minimum to the maximum, kind of that rough idea. It goes from 1 to 6 to give an idea of the spread or the variability in the data. Then finally, our last key feature is this idea of outliers. Do we have any unusual observations in the data? So specifically by unusual, we mean very small or very large. So I'll word it that way. Very small or very large observations. And later on, we will have a formal mathematical definition for this. But for now, this is kind of just eyeballing it, getting a very loose, rough idea. So let's finish this section off by describing the key features for all the graphs that we made before. So let's start off with the histograms. And we had our, let's do shape first. Sorry, let's do these in order. So our key feature of shape first. And remember what we had before. This one trails off to the right very clearly. So what shape would this particular histogram be? Right. Good. Right skewed. I feel a little like Dora the Explorer here, pausing and letting you answer. Let's think about the center. Again, we might have different ideas, but just get a rough thought here. Where is it balanced? Where would that fulcrum have to be? I would say probably this 0 to 2 is where the median would be because we have most of the observations there. So I'll say about 2 grams. What I don't want you to do is say, oh, they go from 0 to 10, so the middle is 5. Don't do that because that would be true if they occurred equally likely between 0 and 10, but they don't. Many more of the observations are down here, so our center needs to be closer to this end. Spread, we're not comparing to anything else here, so just give kind of what we can see from the plot. The spread goes from 0 to 10 grams. Notice I'm not talking about the original data. I'm talking about what I can read, what I can glean from the plot itself. And then outliers. So do we have any observations that have really low or really high fat content compared to the others? So definitely no really small ones because most of them are really small, between 0 and 2. Maybe these guys are outliers. It's kind of hard to tell. Nothing's extremely far away from the rest, so I'm going to say maybe none. Again, we need a formal test to determine, and we'll define that in coming videos. All right, let's check out our stem and leaf plots. This first one for sugar content, we need to talk about shape. And if you look at this, most of the data is just packed into 2 rows here. It's really hard to tell what's going on with sugar content in this plot. So I'm just going to put question marks. This is not a great plot to determine shape. And you'll see in the lab, perhaps, we might look at 5 leaves per stem or 2 leaves per stem, and it kind of stretches this out a bit and allows us to discern shape. But for now, this plot, not a great plot, can't really determine shape. We could still maybe eyeball center, kind of in the middle somewhere. I don't know. Again, we might all have different answers here, but I'd say this 13-ish, 14-ish range. Or maybe even the 12 range. Then the spread, from the plot, we can actually see the original data. So we can see the smallest observation is 0 grams, the largest is 20. So say 0 grams to 20 grams. And then outliers, again, kind of hard to tell because everything's crammed together. Maybe that 20 is an outlier, but I can't really be sure. It's hard to tell. So I'll just put question mark. Not a great plot since everything's all crammed together. This plot, on the other hand, notice it's the same thing as the histogram we had above, so our answers should be pretty similar here. Shape, if you imagine this kind of flipping this on its side, our shape is still definitely that right skewed, trails off to the right or the larger numbers. Center, again, just kind of eyeball. We'll talk about this more formally later. But if you look at the kind of eyeball it, I don't know, 2.7-ish, 1.3-ish, 3-ish, somewhere in there, kind of looks like the middle. Again, we should all have different answers. That's totally fine. Spread, we can glean the spread of the data, 0.0 up to 9.1. And then from here, maybe this 9.1 is an outlier. We can kind of sense that this observation is a lot further, a lot bigger than most of the other data. So I'm going to say outliers, 9.1 grams. That might be an outlier. We would need to do an official test to verify that, but it looks like it could be much larger than the rest of the data. All right, let's check out our last plot here, assessing our key features. So our shape for this one. That's right, bimodal. It kind of has two main areas here, this low sugar content and high sugar content. So grandma's cardboard cereal, my amazing Oreo O's with tons of sugar in them. We can kind of see that easier from this plot. So bimodal would best describe the shape. And then the center for this, again, just eyeball, doesn't have to be exact. I don't know, somewhere around here, 12-ish, I would say. I think we said 13 on the other one. Spread, again, we can see the original values from the plot, so jot it down, 0 up to 20. And then outliers. It doesn't look like the small points are super far from the rest. Doesn't look like that 20 is really far from the rest, so probably no outliers in this case. So again, 4 key features. Make sure you really know these. We won't spell out, hey, tell me the shape, center, spread. You need to know what those 4 things are.